Let's give a warm welcome to Mr. Avil Kumar. Mr. Avil Kumar is the head of software services at Carl Zeiss India, and he leads the software business in Pan India with professional background spanning around of 2 decades. His expertise encompasses technical applications, software testing, inspection automation, turnkey project management, and technical consulting. Having held diverse roles in application, software testing, and product sales at Carl Zeiss India, he brings extensive experience and multifaceted skill set to drive the company's software division. Today, Mr. Kumar will talk about Industry 4.0 and AI. Please welcome Mr. Avil Kumar.
I will take you through how Zeiss, with respect to AI and IoT, is contributing to the manufacturing industry. Just look into one of the video here.
If I had one wish, then I would wish more wishes. Because AI is a technology that can be used in so many application fields to get us into a better future. I am Alex, and I do want to make our world each and every day a bit better. And I'm truly convinced that our way for doing this, and my personal way, is using artificial intelligence. Artificial intelligence is at the core of my personal work, because Zeiss is building and producing machines for many different market segments that produce large amounts of data. Machines for markets like medical healthcare, semiconductor industries, industrial quality solutions. And these machines produce so high quality data at such an enormous scale and speed that no one would ever be able to analyze all of this data. So the only way that we have as humanity, as society, to make use of this data is to have a technology that translates these huge data piles into something meaningful, into the hidden information. And this is exactly where artificial intelligence can be the key enabler. Industry 4.0 is about lifting our industrial processes, our manufacturing processes, to the next level by connecting each and every single step that a product went through, from idea over being manufactured until being used. And one key technology in this process is artificial intelligence, because artificial intelligence allows us to ensure that each machine does what it is supposed to do. We can train algorithmic solutions to find defects in each manufacturing step reliably, efficient, reproducible, and when we integrate artificial intelligence into each manufacturing step, we will end up with products that are error-free, that are produced more efficiently, and that ultimately serve all of us in the way they have been designed to.
Yep. So proceeding, hope we have a good information from Mr. Kundan Das about this industry revolutions. So just want to proceed for the next steps. So the architecture of digitization, where we see major things is like how the data can be pulled into one particular place, whether it may be from the factory environment, it may be from the standards rooms, or maybe it may be from the different equipments, or it may be from the machines. And then when come to suppliers informations, how the suppliers data can be brought into a particular place. And when we come into an inline inspections, so how we can bring the data from the machine lines. So all this information, how we bring together into a particular data and deliver the notifications, or maybe like the reports, with help of digitalization. The process, what normally, as we have shown in the video, like from idea to the production and how the product will be utilized. So there will be like a lot of process and steps. So example, like we have like ballooning in the software, ballooning, which is required from our manufacturing processes. We also need to have many engineering documents like FMEA, control plans, and then comes where the realization of the design to the requirement will happen, like the production happens. So where a lot of measuring data will be generated, and where in which there will be like different process like setup approvals and periodic inspections will be carried out. And more often, once all this data is there, how a notification or non-conformance and reports can be generated, and with this data, okay, how the decisions will be taken. Okay, so those are all the like reports which will enable the management or the user to take a decision. Okay, so that is where the whole solution will work with. So as an example, we have seen like, okay, if the drawing is there, there will be a particular dimensions with the tolerances, how we can, with the intelligence within the software or in the process, okay, how we can bring all these informations where the designer has put all his thoughts behind and made it into a product, and how these informations can be pushed to the production. Okay, so this is one of the process where we make a we build an intelligence to bring all these informations through the auto ballooning, and then directly to a solution where we can generate all the required engineering documents here, so in a specific formats. So once this templates and all this data from the design to the engineering documents is done, then comes how the data can be brought in into this particular matrix. So with it may be like any of the machines, any of the instruments, any of the manual inputs. Okay, so all these things has to be brought in into a particular place or matrix, defined matrix, to take a decision. So that will be enabled with collection of data from different sources and also from the instruments. So once the data is there, so like we have like standard tools, okay, where the experiences of the process, okay, how the process is able to perform, how the trend is going on, and we can do the analytics with all the standard statistical tools. So as we have seen, like nowadays, the life cycle of a product will be like very shortened. So earlier, like one car design used to run for at least 10 to 15 years. But now we are often seeing in the industry that in a year, each manufacturing OEMs are trying to bring new cars in a year, so that how this requirement from the customers, from the market, will be generated in the design phase, and then again it is transferred to the manufacturing industry. So it is very quick. Okay, within 1.5 years, okay, the entire life cycle of the product is getting changed. How this can be handled in the shop floor environment, as Kundan sir told that, okay, how our manufacturing industry in India, okay, need to be enabled, okay, especially from the shop floor base. Okay, this is one of the information where we can bring all the design aspects and the manufacturing data and showcase in a way, in a realistic way, okay, to understand, okay, how the process is performing and what decisions has to be taken, and how the corrections has to be given. So this is one of the examples how the non-conformance reports will be generated. So not only like the non-conformance reports, there are like multiple arms in a factory environment. Okay, like it may be like a shop floor management. Okay, it may be like a gauge management. It may be like a outside the factory environment, like supplier management, whether it may be an audit plannings, okay, or maybe with respect to supplier trainings. Okay, it may be like a tool inspections. So all these things can be moduled and integrated with the IoT to see how the industries can be connected. Okay. So one of the applications where the communication, okay, from the factory environment to the user or a decision maker, okay, that can be transferred via through SMS and with respect to the requirements. So if you see here the control plan requirements, how the frequencies, whether it has been done, okay, where and all the deviations are there. Those informations can be transferred through a solutions here. So some of the few success stories that what we can showcase here is from the powertrain, car body and mold industries and aerospace. So with respect to powertrain, so we can see the IoT, which is functioning in a real Indian environment. So here there is only one place where there is one solution, okay, at a manufacturing area. So where all the documents have been brought into the solution, and once the operator here is working with only the solution with the IoT, and where this is enabled to the customer, and where the final acceptance of the part will be decided by the customer who is sitting at any geographical area. So one of the user, as we have seen earlier, like user guided inspection layouts. So here the user will be able to understand the change in the product life cycle. So where the product, once you see the physical product and the requirement and all his requirements, all the inspection data can be brought into a particular matrix where it is easily visible. So one of the information is like for this particular diameter, whether it is okay or not okay. Once the dimensions is measured, then it is easy to say that, okay, if it is green, okay, within tolerance, and if it is red, it is having some deviation, the operator need to take the decisions, or the software will be able to communicate to the machine to say that, okay, what deviations it has to be taken care. So automated process control, as we have seen from the earlier informations, the whole cycle is being controlled by the solutions. In the mold industry, especially, like we can see like a lot of requirements and which can be brought into this particular solutions, and where we can give or we can provide what customer needs. So one of the example is from the EDM solutions, where we can also work with independently without any solutions. Okay, once this inspection EDM part is manufactured, then we can also work with the CMM, and the other options is like working in an automated cell, okay, where it will be having communication with the machine, with the measuring software, and also with all the tool grips. So one, as we told, with the standalone, and second is the semi-automated, and third is like fully automated production, where we can see cell with the robot also. So are the advantages where how this connected systems, okay, will be integrated. We can see here like all the equipments will be connected each other, and see that there will be like a reduction in the time, and also where the production have been increased. This is one of the example from the complete car body, where the data is being analyzed, captured, and the final decision is being given by the software. So there are like many points or fields where this AI is being incorporated in the measurement or in the metrology. So one of those recent application of this AI and machine learning is with the analytics of the EV cells. So this is one area where now it is more talked in the market, and where we can see a lot of AI and machine learning is brought in this particular segment. Few of the informations, like what all the industry experience we can see is like rejection rate has been reduced, and able to save some amount, able to save some paper, so able to integrate or forecast few of the rejections which can be conquered, and improved process capability from 30% to 90%. So these are all few industry experience with the solution from Zeiss.
Thank you, Mr. Kumar, for discussing about the Industry 4.0 and AI.